Hello students, welcome to the channel. In today's video, we'll discuss the basics of powers and roots, or the basics of exponents, an important topic on SAT and ACT math. This is part of the Basics Explained series in which we take up the fundamentals of the math that you're likely to see on these two tests. I'll link to the series in the description box, so do check the other videos out. Okay, so when it comes to exponents, there are 5 cardinal rules that you need to remember. So we'll look at those rules now. If I multiply two numbers where I'm speaking of exponents and the base are the same, the base of the first and the base of the second number are same, then when I multiply them, I can simply add the powers, right? So this is to say that 2 to the power 3 times 2 to the power 2 is 2 to the power 3 plus 2, 5. And that makes sense because 2 to the power 3 is 8 and 2 to the power 2 is 4, and 8 into 4 is 32, which is 2 to the power 5. So when you multiply two exponents with the same base, you simply add the powers and get the final product. Okay, what about division? If you divide two numbers of the same base, then the exponents get subtracted, right? So again, 2 to the power 5 divided by 2 squared would be 2 to the power 5 minus 2, which is 2 cubed. And again, 2 to the power 5 is 32 divided by 4, we know is 8, which is 2 cubed. Okay, what about x to the power a whole to the power b? So if I have an exponent and then outside that exponent, I have another exponent, then you simply multiply the two exponents. You write x to the power ab. So 2 to the power 2 whole cube will be 2 to the power 6. Now let's see, 2 to the power square, 2 square is 4, and 4 cube is 64, and 2 to the power 6 is 64, right? So it's important to understand that here I was taking one number and then taking the whole number and raising it to another power, right? And so the exponents get multiplied. Okay, what happens with fractional exponents? If I have a fractional exponent of the kind x to the power a by b, then the denominator becomes the root, right? So it's like saying x to the power a by b is the bth root of x to the power a. The numerator stays as it is. So for example, 8 to the power 2 by 3 is the third root of 8 squared, which is the third root of 64, which is 4, right? So whatever is the denominator becomes the root, right? Let's take another example. 16 to the power 3 by 4. This is the fourth root of 16 cube, which is, what is the fourth root of 16 cube? That would be, so I'm just going to write it as 2 to the power 4 into 3, which is 2 to the power 12, and the fourth root of that would be 2 cube, which is 8, right? So 16 to the power 3 by 4 would be 8. And we can verify this by writing 16 as 2 to the power 4 whole to the power 3 by 4, which is 2 to the power 4 into 3 by 4, which is 2 cubed. So whatever is the denominator becomes the root. And finally, if I have a negative exponent, if my exponent is negative, then I simply take the reciprocal. So x to the power negative a is 1 over x to the power a, right? So 2 to the power minus 3 is 1 upon 2 cubed, that is 1 over 8. 2 to the power, let's say, negative 1 by 3 is 1 over 2 to the power 1 by 3, which is 1 over third root of 2. So whenever you see a negative exponent, simply take the reciprocal and get rid of the exponent. Get rid of the negative sign. Okay, let's do some sample problems. So what is the value of this expression when a is half? Okay, so 2a to the power minus 1 plus a to the power minus 1 by 2 whole divided by a. So I can write this as 2 by a plus 1 by 2a whole divided by a. So let's first solve 2 by a plus 1 by 2a. The LCM of the denominators is 2a. So this becomes 4 plus 1. So this is 5 by 2a. So I have 5 by 2a whole divided by a, which is 5 by 2a squared, right? So 5 by 2a squared is my expression. And now I can substitute a for 1 by 2. So let's do that. Okay, so 5 divided by 2 times 1 by 2 the whole squared, right? Because a is 1 by 2. I can cancel out 1, 2 and take out the square. So this becomes 5 multiplied by 2, which is 10. So the right answer for this expression is 10. Question 2, if b to the power a is 1 by 3, what is the value of b to the power minus 4a? So b to the power minus 4a can be written as b to the power a whole to the power negative 4 from that third rule that we discussed. So b to the power a is 1 by 3. So this becomes 1 by 3 to the power negative 4. And 1 by 3 to the power negative 4 will be 3 to the power positive 4 because it's a negative exponent. So I'll take the reciprocal. And 3 to the power 4 is 81, right? So the value of b to the power minus 4a is 81. Question 3. X to the power a squared divided by x to the power b squared is x to the power 16, where x is greater than 1 and a plus b is 2. What is the value of a minus b? Okay, so x to the power a squared divided by x to the power b squared can be written as x to the power a squared minus b squared, right? From the second rule that we saw, the rule of division. And this is given as x to the power 16. So if we compare the two sides, I can say that a squared minus b squared is 16, right? Because the bases are the same. So obviously the exponents have to be the same. And a squared minus b squared is simply a plus b times a minus b. And that is given as 16. Now a plus b is given as 2. And we have been asked to find a minus b. So then if we substitute that, a minus b becomes 8, 16 by 2. So the right answer is option A. Okay. Question 4. Suppose that p is 2 to the power m and q is 3 to the power n. So p is 2 to the power m and q is 3 to the power n. Which of the following is equal to 12 to the power mn for every pair of integers? Okay, so let's first write 12 as 4 into 3 to the power mn, or 2 squared into 3 to the power mn. Why did I do that? Because I have p and q, which are powers of 2 and 3. So I would write 12 as powers of 2 and 3 because I have to represent 12 to the power mn as a couple of powers of p and q. Now, 2 to the power 2mn into 3 to the power mn, right? Because when I separate these two terms, I get 2 to the power 2mn times 3 to the power mn. Now, I have 2 to the power m, right? So if I isolate that, I get 2 to the power m, and I'm left with 2n here, so that goes outside. Similarly, I have 3 to the power n here. So if I isolate 3 to the power n, I'm left with m, so that goes outside. Now 2 to the power m is p, so this becomes p to the power 2n, and 3 to the power n is q, so this becomes q to the power n. And so my answer is p to the power 2n into q to the power m, option D. Okay, sample question 5. The product of third root of 4 multiplied by the fourth root of 8. Okay, so now we are dealing with fractional exponents because I'm going to write third root of 4 as 4 to the power 1 by 3 and fourth root of 8 as 8 to the power 1 by 4. Now, the first thing to do is to make a common base. So I can write 4 as 2 squared. So this becomes 2 to the power 2 by 3. 8 is 2 cubed. So 2 to the power 3 by 4. And then because the base is the same, I can add the powers. 2 to the power 2 by 3 plus 3 by 4. And what is 2 by 3 plus 3 by 4? 12, 3, 4. So 8, 9. So this is 17 by 12. So this becomes 2 to the power 17 by 12. Now, what do I do with this 2 to the power 17 by 12? I notice that I can write it as 12th root of 2 to the power 17, right? But that is not an option, right? I think options A and B I can directly cancel because I'm looking at the 12th root, right? And A and B have the 7th root. So those I can cancel. Now, what do I do with one of these, C or D? The thing about 17 by 12 is that it is greater than 1, right? Because 17 by 12 is 12 plus 5 by 12, which is 1, 5 by 12, right? 1 and 5 by 12 added. So can I write, let me write here. So can I write 2 to the power 17 by 12? Can I write this as 2 to the power 1, 5 by 12? Which means 2 to the power 1 plus 5 by 12. And that is 2 to the power 1 into 2 to the power 5 by 12, right? Because now I'm doing the reverse of what we do. So instead of doing x to the power a times x to the power b is x to the power a plus b, I'm going from x to the power a plus b to x to the power a into x to the power b. So this is 2 to the power 1, which is 2, and this is 12th root of 2 to the power 5, which is 2 times 12th root of 32, because 2 to the power 5 is 32. And so we notice that between C and D, D is the right answer, 2 times 12 to the power 12th root of 32. So this was an interesting question and also relevant because in recent SAT tests, we have seen questions involving fractional exponents. So you need to be able to modify such expressions to get to the answer. Hope this exercise was useful. If it was, hit like and subscribe to the channel. If you are comfortable with powers and roots, do try the advanced practice questions from the Target 750 series. I'll link to those in the description box. Let me know in the comments section what other videos you'd like me to upload. I'll see you in a new video soon. Take care. Bye-bye.